Welcome back. So, in our previous episode, we showed you our replica of the Chernobyl SKALA status display. This device we presented at the exhibition dedicated to the 40th anniversary of the Chernobyl disaster. And honestly, we didn't expect people will like it that much. It actually was one of the central exhibits, along with our SKALA console replica and RBMK reactor control panel. So, following your requests, today we'll show you all the process of building it, and as usual we'll put all documentation and blueprints on our Patreon page, so if you want to build the same, you'll find it all there. The link is in the description below. Previously we took a good look at how it works and what each element means. But if you missed it, the core idea is, it is installed at each reactor unit next to the chief computer engineer's workplace. And here are indicated operations of processors, peripherals and main programs, as well as their critical malfunctions. And it has its quite chilling sound alarm. It is designed to be mounted on a wall, so operators can clearly see it from a distance. And technically it consists of two parts. There is a box-shaped casing with a set of connectors at the bottom, and there is a massive front panel on which are mounted chains of light bulbs and 3 electroluminescent panels. All that is quite heavy, so it opens like a lid of a briefcase to give a convenient access to its internals. We however will use more lightweight parts, so we do not need to strictly follow this very design. But it gives us precise dimensions, so that said, we start Metalworks. We made the casing from two 1.5mm steel sheets, bent and secured with rivets, and at the bottom we added 7 openings for connectors. The front panel will hold the main weight, so it's slightly thicker and it holds on 8 screws, and all openings here have clean cuts. But this was just a beginning, because next we brought it for professional powder coating, and well, it took some time to precisely match the colors, but the result I think looks really cool. Now, before we add 5 rows of those blinking indicators, we need to add inscriptions for them. On the original panel they're stencil painted, so their size actually varies from one reactor unit to another. But we decided to use something more neat, so I found some dry transfer fonts on sale. That is actually a very cool thing. Well, not that much used today, but I have to say I completely love it. Those basically are plastic sheets with letters and symbols that stick to the surface if you apply pressure. It requires a lot of patience for positioning, but the result is simply perfect. And here they are: busy, computer A, computer B, key and restriction. Next, the indicators. Well, they are tricky because they are proprietary for SKALA, they are designed only for it, so you cannot buy them from the old stock as we normally do. So the only option was to take measurements and then 3D print them. Originally, inside those boxes were installed 24-volt commutator light bulbs. Well, you may remember them from our reactor control panel project. And similarly, they'll use LEDs instead. Well, actually, that is pretty much an original approach, because in original SKALA you can see a similar handmade upgrade. As a little side note, what is interesting, those actually the first LEDs Soviets ever produced. They are called AL-102 and this is what they look like. They are not very bright and glow either red or green, but we want to imitate light bulbs, so we will use another modern ones that have closely matching color and brightness. But before I place them, I needed to paint inside space to prevent light leaks. Then we printed the colorful covers on semi-transparent plastic in 2 layers using ultraviolet printer. So first background, then inscription, and this way they look much better. And this is what we got. Each indicator has two tiny protrusions on the sides, so they can be installed in the openings with a click, and then they will just firmly sit inside. Next, I installed LEDs and made two common anode lines we will use to supply them with 5 volts. But, as we need to imitate light bulbs, the LEDs will need to have a visible fade in and fade out. And so, similar to our reactor control panel, we'll use a tested solution for this. It will be 8 16-channel PWM modules. They cost very little, can be arranged in long chains and have convenient headers for wiring. And all the system will run on one single ESP32 microcontroller. Our controller board, just as in the original display, is positioned behind that part of the front panel where inscriptions are. Nice, and now it is time for big wiring. Well, it's important to limit the current for LEDs, so they won't burn out. Each channel of the PWM modules already has a built-in 220 ohm resistor. But it's a little bit insufficient, so on each LED I placed an extra 100 ohm resistor. They will be hidden in starter tubes, and so they will act as stands. On another side of wires, as before, I placed DuPont connectors and then bundled everything together. And here is the very first test. Well, here I found I made a tiny mistake. So, as modules are I2C, each must have own unique address on the bus, you selected with jumpers, and one was conflicting and therefore a few LEDs glowed constantly. But it was easy to fix, just needed to resolder one jumper. In the case you missed the previous episode, those blinking lights indicate operation of 24 functional control groups. And to put it simple, those are specialized interfaces using which SKALA talks to hundreds and hundreds of detectors, controls and subsystems of a reactor unit. Why there are 5 rows? Well, this is because each group at each moment can be assigned only to one of 2 processors, be busy, or it can be disabled by SKALA operator. So technically there will always glow only one light in the column at a time. So I sent a video of this test to actual SKALA engineers and they told me that it looks just like the original. That was really good news, and so we could continue. So next I assembled the sound alarm generator based on the original circuit diagram. We made a detailed review of it in one of the previous videos, so check it out. The alarm speaker is really large. It's installed behind the round opening in the front panel, and in the front it's covered with a decorative frame. Unfortunately, right now I do not have an easy way to make the same from metal, so instead it was 3D printed. Then I placed a piece of cloth and wrapped everything with aluminum duct tape. The resulting frame I secured by melting stands with a soldering iron. Well, I have to say that's a very period correct method. But the speaker itself we'll install later, because, well, it's really heavy and now it will be inconvenient. And next came the biggest work, making the mnemonic displays. They are similar to those you can see in the reactor control room, and the problem is that they are electroluminescent, so they require high voltage. Reproducing them at home with this technology is actually possible, there are solutions nowadays, but it would cost a fortune. So, back in June last year we made a large installation of similar displays based on addressable LEDs, so I decided to do it in the same way, but with some enhancements. For this project we will need around 480 LEDs, they come in chains of 50. We will also need some GST connectors and extra wires for balancing power lines. Those are really important, as each chain has thin wires, while total current can reach amps. So our method was as this. The LEDs are positioned in a special chassis with separators inside, projecting their light at semi-transparent screen. Above that screen there is a layer of brown film, because what is off must be brownish as an original. And above that there is a mask with transparent elements that we will see glowing. The difference is, this time we made each chassis more sturdy, with a solid bottom and ready openings. Previously, the bottom was just a piece of plastic and openings I drilled myself. Well, on one hand it gave more flexibility, on another it was far too fragile. Unfortunately, we couldn't find a contractor that would print them in one piece, so eventually each is made of 4 fragments glued together, but hopefully they will be okay. And then next, using a hot glue gun, I secured LEDs. Well, I prefer to position them in random order and then just light up in different colors and write down what is what. In reality, this is much faster way than making some map first and then following it. And this is what we got. It looks really massive, but in reality it's just one long chain. As I said before, to prevent overloads, it's very important to add extra power lines to each chain of 50 LEDs, and then bring those lines at one point at the power supply. The masks with mnemonic images were printed on 2mm acrylic, but to achieve full non-transparency we need to make it in 4 layers. First goes grey, then white and then to black. And below those masks will be 2mm semi-transparent light diffusers. On them we glue 1 layer of transparent brownish film. Surprisingly, the easiest option to get such a film was just to go to a flower shop and look what they have for wrapping. In fact, it works just perfectly. And when it is all assembled, it will look this way. On the edges I will position aluminum U-shaped profiles that will lock everything into place. And now the first test. Well, to be fair, there were some tiny white leaks, but this is because the underlying white layer is slightly too thick. Unfortunately, it seems such material is not directly available thinner than 2mm, but good news that when the surrounding light is normal, they are almost not visible. Next I found some durable metal hooks and used 4 of them to secure each panel. Well, despite the assembled panels are quite heavy, they hold really well. And finally I installed the alarm speaker. I decided not to place the sound generator inside the device because I want to rework it, so instead the speaker will be connected to the external connector. Fast forward, it works actually quite well. I just needed to be sure that the signal wire goes at some distance from the power lines to avoid any distortions. And speaking of external connectors, I need to prepare and install them. So I've got many of type 2 RMG. They are from the same family as the original display, but have more convenient pinout for our task. Because 4 connectors will be just decorative, but one will serve as the interface to SKALA console, one be for power, and one will be empty inside, and through it will come a USB cable for reprogramming. But before I install them, I needed to add a tiny original detail, inscriptions with connector numbers. Well, you know I like such tiny details, so I also decided to use original period brass screws. Now everything is ready, and all what I needed is to install one part into another, and here it is. So eventually I decided to make a few test programs. One you already could see in the previous video, that's a development of the Chernobyl disaster as it possibly appeared on such a display of Unit 4. I say possibly because no one knows for sure how it was, there was simply no time to pay attention. Another one is a cycled operation that imitates a normal operation of the system with occasional malfunctions, restrictions of equipment and alarms. This we used at the exhibition. And finally, the last one works together with SKALA console, reacting to the operation of computer and those test switches which are above its request devices. This is the operation we will show you in the future, because for now I want to make a new firmware for the console. It will include processing of not just few, but hundreds of SKALA codes and will give some real-like data. So don't forget to subscribe so you won't miss that, and don't forget, documentation for this and our other projects you can find on our Patreon page. The link is in the description below. And we are very thankful to everyone who supports our work, because that helps bring the Chernobyl history back to life in a way it was never done before. And that said, thank you for watching, and we will see you in the next one.